Hello everyone and welcome to my channel. In this series of videos I'm gonna talk about the proof by induction, and I'm gonna explain the proof by induction technique by the very good example of adding or the summation of the first in natural numbers. Here you see the sigma notation, so from I equal to 1 up to n, and then I, as we can write it as equal to 1 plus 2 plus 3 up to the n, and here n is a number greater than 1 or equal to 1. So starting from the number 1, the very first natural number. So we're going to see that how we can just prove. Actually, first we find what is going to be the summation of the first in natural numbers. If we can find a relationship between the n, which is the number that we're going to add up to that number, and also the result. So here is a guess of how we can actually find out the summation of the first in natural numbers. In the example that you see here, I wrote the first 10 natural numbers. So starting from 1 to 10, you see all the numbers. And I want to find out what is the summation of these 10 numbers. So 1 plus 2 plus 3 up to plus 10. What I did here, in the second row of like this example, I wrote the numbers but in the reverse order. So below number 1 I wrote number 10, below number 2 I wrote number 9, and so on. So what I did, I just added all these numbers together, and as you see here, all of them are added and became 11. So what I see here, I see 10 times number 11, so which is going to be the summation of the first 10 natural numbers is going to be 110. However, I added number 1 to 10 twice. So what I have to do is just to divide the number 110 by 2, which is going to give me number 55. So let's just write down what I'm trying to say here. The summation of 1 to 10, I wrote the numbers again. So as you see here, I have 10 times number 10, number 11. So the summation will be 10 times number 11. However, I added numbers 1 to 10 twice, one here in this row and one in this row. So that's, I need to divide it by 2, which is going to be 55. So the summation of the first 10 natural numbers is going to be 55, and this is going to give me a good idea about what is the result of adding the first n natural numbers. So as you see here, this 10 here is actually the number n, and this 11 is just nothing rather than n plus 1, and that's the divide by 2. So I can guess that the summation of the first n natural numbers is going to be equal to n times n plus 1 divided by 2. So, and we're going to prove this like the theorem, or by proof by induction. And I'm going to explain what is a proof by induction. So is it like the technique in math in order to prove that something is true? So some statement or some expression or some phrases are true. So here is what we're going to prove. We're going to prove that, let's call it theorem number 1, that the summation of the first n natural number is equal to n times n plus 1 divided by 2. And again, if you expand, the summation of the n natural numbers is going to be 1 plus 2 plus 3 up to n for all n greater than equal to 1. The induction step, proof by induction has several steps. The very first step is just to show that it works for some basic cases. For example, when n is equal to 1, we're going to see if it's true or not. And then it has something called induction hypothesis that we're going to assume that the theorem that we're going to prove is true for some random number. And by that assumption, we're going to see that if we can conclude that it's going to be true for the next number of that theorem. So let me explain with this example we have here. So the very first step is induction, like the base, so induction base. Which is show that for some small or the very basic numbers or values for n, the theorem is true. So let's choose n equal to 1. So if n is equal to 1, here I'm writing, let's choose n equal to 1 of I, and we know that this is equal to 1 because means 1 plus the next number in the first natural numbers, which is we only have 1, so it's going to be 1, and that exactly is equal to 1 times 1 plus 1, so that's the left side, and that's the right side. So as we see, this is equal to 1 times 2 divided by 2, which is equal to 1, so that means the base case is true. So one more time, I'm going to just write down what we're going to prove. We're going to prove that the sigma of 1 I equal to 1 up to n of I is equal to n times n plus 1 divided by 2, or in other words, the summation of the first n natural number is equal to n times n plus 1 divided by 2. So that's our induction base. So again, just showing for some small value of like the, for example, n or the input, this is true. You might ask, can I choose another number rather than n equal to 1? The answer is correct. However, we're going to just keep it simple and short. For example, I can use n equal to 2 as well, and I can show that it is true because the sigma of I equal to 1 up to 2 of I, this is the left side, is equal to 1 plus 2, which is equal to 3, so that's the left side. And the right side, based on the formula that again we have here, and we're going to prove, it should be equal to 2 times 3 plus 1 divided by 2, which is this is 2 plus 1, not 3 plus 1, so n plus 1, which is also equal to 3. So the right side and the left side are equal to each other. That means that it's true. So for the base case, I'll try to choose a value for the input which is going to be easy to evaluate or calculate. So here n equal to 1 and 2 are simple enough to do that. For sure we can choose n equal to 1000, but it's going to take a long time to calculate the numbers or to add numbers from 1 to 1000. And we cannot for sure use the right side as a formula because that's part of the proof. We're going to show that it is true. So that after having induction base, we're going to just see that how we can prove it for some random numbers, for some random input. The induction hypothesis, we're going to say that, so the second step, we're assuming that for some random numbers such as k, the theorem that we're going to prove is correct. So we're assuming that for sigma of I equal to 1 up to k of I, this is equal to k times k plus 1 divided by 2. So here what I did, I assumed that I'm replacing k, replacing n with k. So as you see here, everywhere in the formula, I just replace n with k. And for sure, because n is greater than or equal to 1, that means that also k is greater than or equal to 1 as well, because k is a random number in the range of natural numbers. So with this, that is true, we're going to go to the third step, which is our induction step. So we're going to prove that if it's true for some induction base, and if it's true for some random number such as k in this range of numbers that we can choose as the input, it is true for some other numbers such as n equal to k plus 1. Here I'm using k plus 1 because as you see in this like the theorem, the next number will be exactly the last number plus 1. If I have 5, the next natural number is 6, the next number after 6 is 7, and so on. So that's why I chose k plus 1, which is exactly the next number after k for the natural numbers. So here, what I'm going to do, I'm going to start with the left side of the theorem. So left side is from I equal to 1 of k plus 1. And again, here what I did, I just wrote n and replaced it with k plus 1, so of I. This is the left side that I'm trying to write. We know that it is equal to the sigma of I equal to 1 up to k of I plus k plus 1. So here it might be a little confusing that how possibly I can write this one as here. Remember, this is 1 plus 2 plus 3 plus k, and here I have plus k plus 1. So what I did, I just extracted part of the expression, which is 1 plus 2 plus up to k, and I wrote it as sigma of I equal to 1 up to k of I, and I just extracted k plus 1 out of this one. So that's correct to write this way. So that's the left side. Based on what we have assumed in the step 2, we said that the sigma of, so here, look at this one, what I have here. I can write as this one as k times k plus 1 divided by 2 plus k plus 1. So again, what you see here has been replaced with this based on what we had in the assumption. So let's see that if this left side can be equal to the right side. So k, so this is equal to k times k plus 1, and I'm going to just use the common factor plus 2 times k plus 1. So I did nothing rather than just simplifying this expression and combining them together. So as you hear, k plus 1 is the common factor, so I can just take it out. So it's going to be k plus 1 times k plus 2 divided by 2, which I can write it this way, is equal to k plus 1 times k plus 1 plus 1, and let me write the plus 1 with the another color, just to plus 1 divided by 2. And that's the left side that I found. And let's see what's going to be the right side. So if you look at the formula again, it says that on the right side we have n times n plus 1 divided by 2. So what I need to do for the right side, I need just to replace n with k plus 1. So here is going to be on the right side. So the right side, I'm going to have n plus 1 divided by 2, which I'm going to replace n with k plus 1. So it's going to be k plus 1 times k plus 1, which is, again, this is n, plus 1 divided by 2. So now if you compare the right side of the this equation and compare it with the left side, so that's what I got from the left side, and this is from the right side, you see that both of them are equal to each other. So why this works, it is because I just chose a random value for k. For sure, k must be a natural number, means a number which is at least 1, and then k plus 1 is any number in this series. So here again, it is an example of the proof by induction. I hope that you enjoyed this video. I will post more videos about proof by inductions. I will provide more examples. However, this was the very first video in the series of proof by inductions examples with this explanation of how it works.